Okay, so this worksheet is going to be on adding and subtracting. Now remember, when we add and subtract, so I'll give you an example here. If we have 2/3 plus 4/5, remember we must get a common denominator. And so in this case, my common denominator would be 15. And so I would need to multiply, and watch how I do this, because this is how you're going to want to do these problems. I'm going to multiply, in this case, both numerator and denominator by 5 to give me 10. And I'm going to want to multiply numerator and denominator here by 3 and get 12. And then again, your denominator just comes down and you add your numerators. Okay? And that would be your final answer. Okay? So that is how we're going to be working these problems. Now some of these already have common denominators, which is going to make it easy. So these two, the denominator is already the same. So I just move that over and I just add my numerators and I get 11. Now we do want to make sure nothing reduces. Okay? So over here on this side we have a common denominator already. That carries over. And then 5x minus 2x is 3x. Okay. Again, let's go back to this one. X could not be 0 because 0 times 15 would give me 0. Okay, here's this one. Common denominators already, so that just comes across. And I add the numerator, 4x plus 7. Okay. Again here, my denominators are the same. 5 minus 2 is 3. Okay. In this case, my denominators are the same. And we're just going to add up the numerators. Now, there are times when these may, oops, sorry, did that without you seeing it. There are times when, again, these may factor and reduce. But on this page, they don't. Again, I keep forgetting to go back, but x cannot be, again, you set that equal to 0. This would be a negative 3/2. Okay, a cannot be 0, because 0 times a is 0. And in this case, I would factor that, and so I know that y could not be 3 or negative 3. Okay, so that's what you're going to do on all of those. So those are pretty easy because they already have a common denominator. But do be careful just in case you get to something like down here, that once you add those, make sure that you cannot factor and reduce. Okay? So now let's look at when the denominators are not the same. Okay? So the denominators are not the same. So I need to make them the same. So in this case, I'm going to need an 8, and I also need an x. So what you need, guys, is one of each of the factors. Okay? So when I go to get a common denominator of 8x, then that means that this one still needs an x, and again, I multiply both the top and the bottom. So that gives me 5x. So see, when I reduce it, it still goes back to the 5/8. Here, I already have an 8x, so I don't need anything else. Okay, so my denominators are the same. Add your numerators, or in this case, subtract. And again, x could not be 0 because 8 times 0 is a 0. Okay, number 2. Okay, I want to make these look the same. And sometimes when you are doing these, it's easier to factor first. So if you look, this has a common 4 in it. Okay, so when I go to do my denominator, okay, I need a 4, and I need an x plus 3. Don't repeat. So just because there's an x plus 3 here, I don't put another one here. I need one 4 and one x plus 3 for this one. For this one, I need an x plus 3. Well, I already have it. Okay, so now when I look at this, I've already got this denominator. I don't need to multiply by anything. But on this side, I have the x plus 3. I don't have a 4. So I need to multiply numerator and denominator by 4. Now this would be a distributive property here, and if you have a binomial, I'll show in a little bit, you would need to distribute. That's a 28. Now my denominators are the same. So I'm going to bring it down. I'm going to add my numerators. And it looks like I'm done, but in fact, I still have 20 and 4 that I can reduce. Okay? So I know that 2 will go into 4 twice, and 2 goes into 30 15. And so my actual answer here is 15 over 2x plus 3. And again, x cannot be a negative 3. Okay. So let's do one of the, we'll just do this one over here, number 3. Okay. So again, for this one, I'm going to need an x plus 2. Okay. I also need an x minus 5 for that one. So I'm going to take one of each factor. That's just the easiest way to remember it. Each factor you need. So I need this factor and I need this factor. Okay, one of each. Okay, so now this one has an x plus 2. I need the x minus 5. Okay, and this, again, that's your distributive, or FOIL here. Here's your distributive property. And I would go ahead, you could skip a step. You could, I'll just write it. You could write it this way first, or what I was getting ready to say, you could skip a step if you can just kind of do that in your head and go straight to there. That would be acceptable. Okay, here I have the x minus 5, so I'm going to need the x plus 2. I'm going to need the x plus 2. Okay, this one is, you got to be very careful. Subtraction is the tough one. Okay, it's the one that's going to mess things up. So when I distribute here, well, I'm going to rewrite it like I did the last one. And then now when I distribute, I get this. Shoot, take that out. That's not there. 4x plus 8. Okay, so what I want you to see is there is a minus sign out in front. So remember what we have to do if there's a minus, we add the opposites. And I know a lot of you are going to say, well, I don't need to change it like that. I can keep it in my head. Great. But I can tell you, half of you think you can keep it in your head, but when you actually go to do the problem on a test or something, you'll forget. So just get in the habit of changing it to an addition and then changing however many signs you have up here. So again, my common denominator is here. I'm now going to combine my like terms, so 7x minus 4x, negative 35 minus 8. Okay, and again, one thing that you would need to do here is always go back and look and see would this factor, and could it potentially cancel something. Obviously 3 and 43 is not going to reduce, and so you're done. You also need to state again that x cannot equal a negative 2 and 5, positive 5. Okay, so this would be your final answer. Okay, and this one up here. Okay, does that make sense what I did? Okay, I'm going to do one more just so we don't go too long. So on this one, since this is a trinomial, if you have a trinomial, you're always going to have to factor it. So what are factors of 10 that give me 7? And it's 5 and 2. So now when I come to get my common denominator, this one needs a y plus 5. This one needs a y plus 5. Well, I've already got it. This one also needs a y plus 2. So again, you don't need to repeat the factor unless it occurs twice over here. If it occurs twice, then it has to be here twice. But if it only occurs once, it only needs to be down here once. Okay, so again, I've got the y plus 5. I need the y plus 2. Okay, so this is going to be a distributive property. This one I'm going to shorten the step. And so 3y plus 6. Again, if you need to back up and put this step in here that I did in the last one, then go ahead. Here I need a y plus 5 and a y plus 2. Well, I have them already. So I don't need anything multiplied. So there is my, I've got my common denominators now. Okay, and I'm going to combine my terms. This one's a plus, so I didn't need to do anything. So there's 4y plus 6. Okay, now you can see that there is a common factor of 2 here. If I take a 2 out, here's the question. If I take a 2 out, would I get either one of these? Okay, and hopefully you know the answer is no. And I could do that. So if I take a 2 out, I'm going to get 2y plus 3, and then y plus 5, y plus 2. So either of these would be acceptable answers. Okay? Why you would need to do this one again is just in case something canceled, but it didn't. And if you could see that it wouldn't cancel, you wouldn't need to write that. Again, y cannot equal -5 and a -2. Okay, so this is your examples of adding rational expressions when you have to get your own common denominator. So you're going to finish all of those.